Hello everyone, this is Vishnu and my Tech Talk video is on IBM 360 370 with respect to computer organization and architecture subject. So let's get started. So this is from a paper. So at the beginning, um, the Andrews pages and another person, both of them had undergone through an interview, and this is what it looks like. So, Andrews page at the beginning, Andrews pages had decided to divide the implementation of this into two parts. So, which is to be specified and to be left unpredictable. So, specified in the sense the features or the capability um, of the PC or of the chip. So specified or unpredictable, those are nothing but the features or the things which can that chip can do or the PC can do. That computer actually, it's not a personal computer. So they decided to divide it into to be specified and to be left unpredictable. So to be specified in the sense it can do additions, multiplications, arithmetic operations, and so on. But to be left unpredictable, they know that it works, but they are not so sure about it. So they left so like that. What that's what means unpredictable. So and wanted to coin it as an unpredictable rather than undefined because it would lead to more costs and investments so of time on older models rather than working on new ones. So developing the old models from time to time would lead to getting behind in the race, so which would lead to the shutdown of the company for some time, maximum a lot of times, because they're not coping up with the evolving technologies. So just developing the old technologies would lead to um, uh, company going bankrupt or something else. So that's how they divided the implementation process to be specified and to be unpredictable. So coming with the architecture, actually this word architecture was coined by a uh, project called 8000, which was implemented by implemented at it's a place Poughkeepsie, Poughkeepsie, if I'm spelling it wrong. So um, actually these both projects have undergone at the very same time. Um, so from there, the architecture so-called word has been came into existence, saying that actually if we want to reference what architecture in nowadays, it's ARM architecture, which is mostly used in mobile phones. Now Apple has introduced that into Mac as well. ARM architecture, which is very power efficient and yeah. And other one is x86 architecture, which is being used in personal computers till date. So all Intel and AMD processors are based on x86 architecture, while x86 or something latest, but um, on that architecture, these Intel and AMD chips or Ryzen processors have been designed, and all each and every mobiles, let's say Snapdragon or MediaTek processors, uh, or Apple's M series or A series, which is for their iPhones or iPads, I guess. Those all processors are nothing around are based on ARM architecture. So, so this is what architecture means in today's uh, until today. So up to date, sorry. So people were working on the project believed that they can use the same program across three different machines. So which is a very which is a thing which most of the companies try to do is uh, try to implement the same thing in different projects. This thing is not only implemented in this field but in automobile industry also. You can see two similar cars with the same with different logos on them, or same vehicle of same company but same internal design in the sense, let's say, the hardware which is present but just the outer body is what is going to be changed. So this is what actually companies do. They try to do to reduce costs of manufacturing. So um, for this they believe that three different machines with a total performance span of 7 to 1, but in the IBM line for 360 lineup, and the range of in performance was of 20 to 1 over six different designs. So they could implement the same thing in six different designs with a performance ratio of 20 to 1 for the 360 lineup. So as I said, six different designs is nothing but the outer thing will be changed, but the internal program or internal hardware which is there will remain same. That won't change, but the outer how it looks, or let's say how it responds, are something which are different. So with the help of this, companies can reduce costs and time of research they spend on, so they can move on to new models. So that's how basically companies work. So moving on, model and architecture. So this has been explained by both of them, uh, Andrews and Pages, I think. So an architecture is a realization of and implementation of a model. So or it is a reflection of a computational model. So and a model is a electrical and physical design with a production cost, production schedule and price of it is a physical embodiment of the architecture. So model is something which exists in front of the eye, but an architecture is nothing but a realization or an implementation of a model. Like it could be in a paper, and model is nothing but the physical product that you can touch and feel. But architecture is nothing something which you cannot feel or touch, but you can look at it. Like let's say diagrams on paper and etc. So moving on, vector processing. Vector processing was one of the useful things where what vector processing means that it's a processing of an array, where array is something like data set at consecutive memory addresses. So vector processing is something but going through processing the elements inside the array, or going through array operations, let's say sorting, or going through the array, storing names or storing where, so storing numbers or so on, or storing data sometime few times. So vector processing was one of the things which has been implemented, which was there, which was not unpredictable, but they did it. So vector processing was there. So, but it was an optional feature though for the central process instruction and execution elements, where a few more elements were required in addition to implement vector processing, say like registers or something else. So this allowed the processor to execute a vector arithmetic and logical operations up to 128 sets of operands with a single instruction. So the vector facility is used for scientific and engineering applications such as structural analysis, computational fluid dynamics, adds 191 new instructions and 16 vector registers, um, each containing 128 elements. So For implementing vector processing for this 360 370, they needed 16 vector registers, special registers for vector processing, and 191 new instruction sets. Let's say for adding elements into the vector, or removing them, or creating a vector of so and so size, or allocating the memory, and so on. And 16 vector registers to deal with the data, or collecting specific data only from the vectors, so which are only dedicated to vectors. These registers will store the data and send it to the processor and get it, and after processing them, and they will look after it, or send it to the same register, or send it to different registers for implementing different processes and so on. So um, vector processing was something which was implemented in 360 and 370. So moving on. Yeah, thank you. And as you can see, left side it's 360, and at the right side it's the 370. There's a number of I mean, it's not combined. It's single unit, which is 360 at the left, and a single unit 370 at the right. So that's it. Thank you.